In this session, let us discuss about OC test, SC test, and also some of the books suggest for OC test HPF wattmeter should be used or LPF wattmeter should be used, and for SC test HPF, LPF like that. About that also we are going to discuss in this session. Okay, first of all, if you think of OC test, okay, let me have a small recap. Basically, OC test should be conducted at rated voltage and at rated frequency, first thing, and we are going to get the shunt branch parameters. Okay, shunt branch parameters R0, X0. Here you will come to know voltage supplied, current flowing through this, wattmeter supplied here, or kind of power being supplied here. So by W0, V1, I0, we should be able to, what they say, find R0, X0 value. We know that this is pi naught and this is V1, minus A1 equal to V1, and this is I0. So this is no load power factor theta naught, and this is I mu, and this is IW. IW is going to flow through this. I mu is going to flow through this. Okay, now I naught theta naught, I naught cos theta naught is IW. So first of all, theta naught has to be found. We know that V1 I naught, source voltage, source current, and power factor angle between that. So V1 I naught cos theta naught equal to W naught. So from here, cos theta naught you are going to find. I naught value already you know, ammeter reading. I naught cos theta naught is going to be IW. I naught sin theta naught is going to be I mu. I naught cos theta naught is IW, and V1 divided by IW is going to be R naught X naught. We can find that way. Okay. Now if you think of SC test, okay, SC test, the moment it's linear parameters, series branch parameters, at any current with any non-zero frequency test can be conducted. So this equivalent circuit is this. Okay, so this is RA, this is XA, and this voltage is VSC, current is going to be ISC, and wattmeter is going to be WSC. Okay, ISC square RA equal to WSC, you can find RA. VSC by ISC is going to be ZE. ZE square minus RA square equal to XE. That way we are going to find that side. Okay, now let me think of one example. Maybe our 250 volts by 2500 volts, our favorite transformer. For example, the machine given is 10 kVA. Okay, 250 volts by 2500 volts transformer. Okay, upon this, we would like to conduct OC and SC test. Now, OC and SC test, either I can conduct an LV side or HV side. For example, let me think of, I would like to conduct OC test. Okay, OC test, if I conduct on LV side, what are the requirements? On HV side, what are the requirements? Let us see. Okay, OC test means that rated voltage, rated frequency should be supplied. Means all over India we have 50 Hz frequency only. So for OC test, basically rated voltage has to be supplied. Now how much is the rated voltage? 250 volts. So first of all, 250 volts source should be there. Okay, in order to measure whether you are supplying rated voltage or not, 0 to 300 volts MI moving iron, in order to measure RMS value moving iron, and in order to measure average value PMMC instrument. Okay, anyway you will come to know in measurements. Now for example, let me calculate full load current on LV side. Okay, so how much is full load current on LV side? Is going to be 10 kVA, 10,000 divided by 250 volts. Okay, so is going to be 40 amperes. Okay, now in OC test, how much current would flow? How much will be I2 in OC test? 0. So how much will be I1? Is only no load current. How much will be the no load current? 2 to 6% of full load current. 6% of full load current is going to be 2.4 ampere maximum. So I can think of 0 to 5 amperes MI. Okay, and my wattmeter rating is going to be 200 divided by 5 amperes. 200 volts divided by 5 amperes. This is going to be a wattmeter rating. Now, if you want to conduct OC test on HV side, high voltage side, my 2500 volts has to be supplied. So 2500 volts source should be there, because OC test should be conducted at rated voltage and at rated frequency. So in order to measure whether you are going to supply 2500 volts or not. So my voltmeter, okay, now the moment its voltage is high, okay, MI instrument with shunts we can use, or we can think of like what do you say, current transformer, potential transformer, maybe by using potential transformer and all we will measure. So I don't want to write anything MI or something. Okay, now HV side, full load current on HV side is how much? HV side is going to 4 amperes, because 10,000 divided by 2500 is going to 4 amperes. Now if full load current is 4 amperes, how much will be no load current? No load current is going to be 2 to 6% of full load current, or maximum 10%, in the sense 0.4 amperes means that I may have to use 0 to 0.5 amperes. Now my wattmeter is going to be 3000 volts by 0.5 amperes. Wattmeter should be used. Now let us think of SC test. Okay, so if you think of SC test, okay, in SC test, basically SC test can be conducted, of course, as I have been telling you from starting, depending upon the situation I will change everything, because machines application oriented. Okay, there will be no specific rules and regulations here. So in machines, basically contradictory statements we should be able to digest properly. Okay, so for time being, SC test in the sense till what maximum current I can load the transformer to rated current. So SC test, if I conducted on LV side rated current is 40 amperes. So maybe if I think of ammeter, 0 to 50 amperes ammeter. Again, shunts and all can be used, or CT can be used, because current capacity is more, 50 amperes. Now, if you think of, in order to circulate rated current, how much should be the short circuit voltage to be supplied? 6 to 12% of rated voltage. Rated voltage is 250. Okay, so 12% of 250 or maximum 20% is going to be 0 to 50 volts. I can write MI here, because less voltage only. Now if you think of wattmeter, because in each test I have to connect voltmeter, ammeter, wattmeter, so this is going to be 50 volts by 50 amperes. Wattmeter should be there. Okay, now let us think of SC test. If I conduct on HV side, how much is HV side rated current is going to be 4 amperes. You can conduct your SC test at any current level, but maximum current can be 4 amperes. Okay, so this is going to be 0 to 5 amperes. MI. Now, in order to circulate rated current, how much should be the short circuit voltage to be supplied to circulate full load current? Is going to be 2 to 12% of rated voltage HV side, maximum 20%. 20% is going to be 0 to 500 volts. So 0 to 500 volts, MI. Okay, now if you think of wattmeter, I can say 500 volts by 5 amperes wattmeter. Okay, now let us see which side is better to conduct. Basically, depending upon the situation, everything will change. Okay, now in this 250 volt source. Okay, so if you think of our household application, roughly 230 volts you are going to get. Now if you keep dimmer stat or variac, means you can raise to 250 volts very easily. So 250 volt source is easily available. And 0 to 300 in the sense phase to neutral, our supply voltage from the electricity board is roughly 230 volts. Now the moment it's 230, in order to measure the 230, each and every laboratory, okay, not only engineering college laboratory, polytechnic college laboratory, even not even polytechnic, like ITA college laboratory also will have this 0 to 300 volts. And 0 to 5 amperes is going to be very normal current. Okay, if I have 10 fluorescent lamps, roughly current will be the same, 5 amperes. Now normal voltage, normal current, it is easily available. Now if you see the other side, 2500 volt source is not easily available, 2.5 kV. Even if you have that, how to switch on that? High voltage is going to be difficult. 0 to 3000 volts, very high voltage, not easily available. 0 to 0.5 amperes MI can be easily available. Maybe we can take it from electronics guys, ECE guys, analog, means from there we can collect one ammeter. Okay, because 0.5 amperes is not a current for us, frankly speaking. Okay, very huge voltage, very less current, not easily available. So I can say that maybe, I repeat, maybe it may be better to conduct OC test on LV side. Okay, I repeat, it may be better to conduct OC test on LV side. Okay. Now let us think of SC test. 0 to 50 amp is very huge current, not easily available in each and every laboratory. And 0 to 50 volts, okay. Very less voltage, very high current. Now if you think of normal current, line to line voltage, if you think of in our normal household application, it is 440. In order to measure that roughly 440 volts, you are going to get 0 to 500 volts voltmeter. Very normal voltage, very normal current, it is easily available. So we can think of, again I'm repeating, it may be better to conduct SC test on HV side. Okay, so I can conclude that it may be better to conduct OC test on LV side, SC test on HV side, SC test on HV side. Okay, now all about machines, I'll tell you one thing. We should not restrict to one thing, because my machines is all about application. Okay, so my machine is all about application. So depending upon the application, everything will vary. As I told you previously also, means air gap in the rotating machine should be less or should be more? Should be less. Yes, it should be less, because in order to reduce magnetizing component of current or field current, it should be more to reduce noise levels. So in machines, both the contradictory statements we should be able to digest, and depending upon the application, we have to select which type of analysis should be done. For example, if I think of one transformer which is having 250 volts by 25 volts transformer, 25 volt, if I have that transformer, now upon which I have to conduct OC test and SC test, if you see. Okay, so where to conduct OC test? Normally I said previously that it may be better to conduct OC test on LV side. So can I conduct on LV side or HV side OC test? HV side. Why? 250 volt source is easily available. Okay, now I will conclude, just wait. Now if you think of SC test on HV side or LV side should be conducted, SC test also should be conducted on HV side only. Why? Because basically whatever the conclusions we got here, it is not thumb rule. Okay, so they are not thumb rules like OC test always should be conducted on LV side and SC test always should be conducted on HV side is wrong. Okay, because depending upon the application, how you concluded this, depending upon availability of measuring instruments and sources. Okay, so depending upon availability of measuring instruments and sources only, you decided this. Now if you come to here, which is more available, depending upon availability of source for OC test, because for OC test I have to conduct OC test with rated voltage. 250 volt source is easily available. 250 volt source is easily available. Okay, now if you think of SC test, okay, how much voltage should be supplied to circulate rated currents and SC test conditions? 6 to 12% of rated voltage. Okay, for example, if you think of 10%, for example, how much voltage should be applied here in order to circulate rated current? If you conduct your SC test on LV side, 2.5 volt, but here this is going to be 25 volt. Okay, means that if you keep some dimmer stat to vary the voltage, at least you can touch and you can rotate a bit in order to get 25 volts in this case. But in order to get 2.5 volts, it is very difficult. Okay, so always we have to keep in mind, that always my availability of sources and measuring instruments only will decide while conducting the test, OC and SC test, on which port we have to conduct OC or SC test. We have to keep 2 stars here. Okay, so availability of measuring instruments and sources only will decide that upon which port we have to conduct OC or SC test. Port in the sense LV port will be there, HV port will be there, 2-port network kind of. Okay, now next thing is we have to think about the power factor. Now let us try to draw phasor diagram for OC test and phasor diagram for SC test. Okay, so if I think of phasor diagram for OC test, okay, so this is pi naught. Okay, so this is pi naught, phasor order of rotation, and now this is minus E1 is nothing but V1, Okay, so this is minus E1 is nothing but V1. Now, if you think of my no load current, okay, so my no load current is going to be I0, in which I mu component should be more, I mu component should be more, IW component should be less. Okay, means that IW component which is in line with V1 should be less, I mu component which is in line with pi naught should be more, What does it mean? If you think of the angle between here and here, which is theta naught, should be more or less? More. At least this theta naught vary between 70 to 80 degrees or 65 to 80 degrees also can be said. Okay, so the moment theta naught is more, what is the power factor here? Is going to be very low power factor. Okay, so in measuring instruments, like in wattmeter, current coil will be there. Okay, so potential coil will be there. Okay, so through current coil, current will go, through potential coil, potential current will go. Or as this is more or less resistance only, voltage across this is Vp. Voltage across this and current flowing through this almost in line in your wattmeter. Now, means I can say that means how wattmeter should read the reading means current flowing through the current coil multiplied by voltage across the potential coil multiplied by cos of the angle between potential coil voltage and current coil current, it should read. Okay, but under low power factor condition, deflection torque between this I component of current and IP component of current, when the angle is more under low power factor condition, means deflection torque developed is going to be less. Okay, so in order to compensate under low power factor condition, in your measuring instruments, we will add one more current coil here in parallel with the existing current coil in order to improvise the deflection torque to show you the reading. Okay, so I can say that under low power factor condition, we have to compensate the wattmeter. So means we call such a wattmeter as LPF wattmeter. Okay, so in OC test I can say that LPF wattmeter only should be used. Now let us think of SC test. Okay, so if I think of SC test, if I try to draw the phasor diagram, for example, this is VSC. Okay, so this is short circuit voltage. Because in SC test, what was the model? This is the model. So this is going to be VSC. Current flowing is ISC. So ISC should lag behind VSC by tan inverse of X by R. Now this is RE. This is XE. Okay. Now if you try to draw ISC, let me write this. ISC should lag behind VSC, and ISC into RE plus ISC into XE is nothing but VSC. Okay. Now if you think of ISC, okay, now ISC, let me take more, not a problem. This is going to be ISC. Okay, now if you see ISC into RE1, maybe 90 degrees to here, yes, okay, here it is 90. Now anyway, let me think of this. Okay, so this is going to be ISC into RE1 plus ISC into XE1, so this is going to be theta SC. Now ISC into RE1 should be in line with ISC. Okay, and ISC into XE1 is 90 degrees with respect to ISC into RE1 plus ISC into XE1 is nothing but VSC. Okay, theta SC equal to tan inverse of opposite by adjacent. ISC into XE1 by RE1 is nothing but XE1 by RE1. Okay, so theta SC is nothing but tan inverse of XE by RE. Okay, first of all, you have to trust me. I repeat, you have to trust me. Without proper research, I wouldn't share like this. Okay, maybe textbooks might give so many things, because in literature means depending upon the textbooks, they do some mistakes. But in the problems, they cannot do mistakes, because normally problems will be collected from the practical things. Okay, now basically this theta SC power factor, in order to use whether it is LPF power factor meter or HPF power factor meter or UPF power factor meter, we have to know this theta SC value. Now already we know that X by R ratio of transformer should vary between 2 to 6. Now, what is the power factor under short circuit condition is going to be cos theta SC. Okay, equal to cos of tan inverse of XE by RE. Okay, now if I think of X by R ratio of 2, shift tan inverse 2 cos 0.447, so 0.447 to cos of tan inverse of 6, 0.164. Okay, so this is going to be 0.164 PF lag. Okay, so the variation is going to be 0.16 to 0.44. So logically speaking, is it low power factor, high power factor? Because as I told you previously also, if king's first wife is good, okay, if king's first wife is good, does not mean that king's second wife is bad. Okay, first wife might be good, second wife also might be good. We have to investigate her separately. Okay, similarly means we should not follow textbooks like OC test is LPF wattmeter. I am also accepting. That does not mean that SC test should use HPF wattmeter. Okay, let us investigate SC test separately. Now, what is the power factor range you got? Power factor range you got is 0.16 to 0.44. Okay, or I can say 0.2 to 0.4. So this particular power factor, is it low power factor or high power factor or unity power factor? It is also low power factor only. Okay, so in SC test also we have to use LPF wattmeter only. Trust me, I should be right. Okay, because of course in some of the textbooks they are saying that OC test it is LPF, so SC test it should be HPF, they are saying. But in the same textbooks, go through the problems. They will give you in SC test my power factor is 0.2 PF lag. Okay, but 0.2 PF lag, 0.2 power factor is a low power factor only. No, what is high power factor? Unity power factor 0.95, 0.9, 0.85, 0.8. All these things I can say high power factor. And one more thing I have to add here. What is that? Basically in wattmeters we have LPF compensated wattmeter and we have normal wattmeter. We don't have HPF wattmeter at all. Okay, if you get any doubt, go to your machines lab and check the wattmeters. Okay, so basically HPF, normally in some textbooks HPF they mentioned HPF wattmeter will not be there. HPF wattmeter will not be there. Normal wattmeter will be there, which is compensated for low power factor. Okay, normal wattmeter will be there, unity power factor wattmeter or normal wattmeter will be there, and another wattmeter will be there which is compensated for low power factor. So LPF wattmeter will be there, we are not using here. LPF wattmeter will be there, normal wattmeter will be there. There is nothing called like HPF wattmeter as textbooks suggest. Okay, one time IIT Kanpur has given one question, that is LPF HPF. They followed as if like this is LPF, this is HPF, they followed, but in following that also LPF HPF should not be used. LPF can be used for OC test and LPF only should be used for SC test also, but they use HPF. So under that conditions they are following some textbook, though we know the things, because in examination somehow we have to answer it and come out. But in the interview we can fight. In the interview, if interviewer say that we have to use HPF wattmeter in transformer SC test conditions, then show your capability, show your caliber, and prove yourself that you are right. But in the exam, if they give you any question, of course, only in complete gate era, only one time they have given upon this LPF, HPF. Okay, they used LPF terminology for this OC test, and they used HPF for SC test, but that is wrong. That is wrong. But in the exam, in future also for gate exam or ESC exam, if they give you LPF, HPF, just consider it as depending upon the options given. Consider it as if this is LPF and consider it as if this is HPF. Okay, but ideally they should not give that question. In the interview, show that my SC test, for that SC test also wattmeter should be LPF wattmeter only. Okay.